So today I'll talk to you about the inspirations we draw from meerkat behavior. So basically we want to use these inspirations to construct natural, artificial, and organizational intelligence. And there was a symposium last Thursday, in OGGB, business school, and I gave the master talk. And I'm sorry if you were there last week, but basically I'll talk about the same thing. Okay. Yeah, the title is Meerkat Embodied AI. So my name is Chen. So let me start with a question on some of philosophy, a question on mind and reality, and also related to the origin of intelligence, not only for natural intelligence, but also for artificial intelligence and all kinds of other intelligence. So think about, so what creates an image of reality in our brains? Because, for artificial intelligence and all kinds of other intelligence, so basically we do every day, every moment, is perceive the reality from the external world and react to the perception. So the question is, so what creates the image of the reality in our brains? So let's take a time travel and back to the ancient Greece. So Plato tells us mind creates reality, and we can change mind to change reality. So basically, we can understand this as the mind controls the reality, and the reality or the intelligence is somehow an incarnation of the mind. And later on, the theory of mind tells us mind can be regarded as a computational system, because it's input as information from the external world and output some actions driven by some regular signals. Reward can be simply a good meal you have your dinner today, and it can also be achievement of some goals at a more abstract level. So the theory is so important and so nice because it connects computer science, the mind, and intelligence. So basically it tells us we can implement mind, we can implement intelligence through a computation model. It can be just a computer machine. But later, we have the theory of machine systems. It tells us our world contains more than one agent. And one instance of the world is actually this room, because I'm talking and you are listening and thinking. So we actually form a small world. So with all of this, we can have the assertion that our world is created by organizational and computational system. So with this sort of understanding, let's go back to think about, so how can we understand mind from natural and organizational intelligence? Because once we understand mind, we can design some sort of artificial intelligence guided by the understanding of the mind from natural and organizational intelligence. And one example, of course, can be the meerkat. It's the cutest animal, or one of the cutest animals from Africa, right? And it can show some very interesting behavior. So the question is, ask how can we infer, or how can we know the incentives behind this meerkat behavior? And we try to seek answers from machine learning. And luckily we have the reinforcement learning. So in the context of mind and reality, we can say that reinforcement learning is a process of creating reality driven by some rewarding system, which means that their actions are formed by the state of the mind in our brain. But it's not good enough, because we do not want to know the reality created by the reward, but instead want to know the reward after the reality. And luckily again, we have this theory of inverse, or have a method of inverse reinforcement learning, so where we can infer the root function behind the observed reality. So how could we use inverse reinforcement learning to infer the state of mind of natural intelligence? So first of all, with the root function, we can understand the motivations behind the different behavior of meerkats. Not only for each individual behavior, but we can also infer the motivations between the transitions of this behavior. For example, so currently a meerkat can look for some food, and next time it can dig the ground. So why this transition happens? We can use the root function to interpret this transition of behavior from looking for food to digging the ground. Or it can also be guarding and stand by to guarding the whole community in their enclosure. And then secondly, with the root function, we can design an environment for artificial intelligence agents so that our expected behavior emerge as a result of reward maximization. And one example is you have a generative model. It can be a large number model, and we want you to generate a 3D model that can be recognized by a 3D printer. So with the root function, you can optimize and refine the quality of the 3D model by maximizing this root function. And this is exactly OpenAI is doing. They use somehow they call the human feedback. They hire a group of people to evaluate the output of their large language models, and namely they call it the human feedback. And actually, this, the underlying method is reinforcement learning. So how far did we go in the way towards embodied AI driven by Meerkat? It's actually the collaboration with Wellington Zoo, where we capture a lot of footages of meerkats in Wellington. And by applying some computer vision techniques, we extract a tabular data from these footages. And each piece of data in the table records the behavior or trajectory of each individual meerkat. And by closely working with some PhD students in the School of Computer Science, we apply some causality discovery model based on this tabular data, and we generate a causal model. The causal model captures the correlations between two different behaviors. So for example, they can carrying pop, and the next behavior can be digging. So the causal model tells us the correlation among the different types of behaviors. And based on all of these, we develop a series of methods which we collectively call them Meerkat reinforcement learning. And using this type of reinforcement method, we can generate some virtual meerkats, or even a mechanical meerkats that can interact with real ones. And the ultimate goal here is to find some ethical patterns hidden in this meerkat behavior, because we want to transfer the ethical patterns to the real robotics. And once we can find these ethical patterns, we can design some sort of real robots that have ethics and moral. And that's our ultimate goal here, but it may take like 5 or 10 years to achieve it. Okay. But our story is actually beyond Meerkat. Actually, our story starts from a theory found in multi-agent systems. So this story, the theory tells us basically using a centralized method, we cannot find a root function that aligns with each individual agent's interest. So this means that we have to use a decentralized method to find a root function that can satisfy each individual agent's interest or objectives. And based on the theory, we develop a several methods. So this method can deal with imperfect observations of meerkats, for example, and can also deal with heterogeneous agents. So heterogeneous means that an agent can have different objectives and different root functions. And our application is again beyond meerkat, because we also apply to some scenarios of traditional reinforcement, traditional artificial intelligence, like Kachi just said, for example, the traffic, because we can use our method to advise on the strategy to look for passengers for the taxi drivers. It can be Uber, people use every day, or it can be Didi, people use every day in China in particular. And we can increase the average profit of these drivers using our method. And our story does not stop here, because as I just said just now, we want to find some ethical patterns. And once we can find some ethical patterns, we can design some sort of ethical AI. And one example can be an agent hospital. So basically, it's a simulation of real hospitals. And once we can build such a simulation system, it will be a win for both hospitals and patients, because patients can get personalized and better medical treatment, and the hospital can benefit from a lower operational cost. So these are ultimately go along this line of research. So this is basically I want to talk about today, and the more information can be found in our papers. And happy to take any questions.
Thanks.
Yes.
Hello. So this one here, it's interesting that it applies on the topic, on the aspect of animal behaviors. What about, for example, in terms of crime investigation? For example, if you find a suspect, can you use your technology to map the mind of the suspect, and whether that person is lying or whether there's withholding, the person is withholding vital information?
Well, to do this, you have to, so first of all, you need to have data with emotional characters, and then you can build a model on top of that kind of data. So without emotional characters of your data, I don't think you can figure out any emotional patterns in your data. And the emotional content could be the way you talk, or it could be the way you you take some general behavior, like your so basically how you talk to others from your basically from your talking. I think there exists some models that can figure out the emotional characters from your talking. Yeah. Well, yeah. I think for animals it's definitely easy, to figure out some emotional content than humans, because humans can sometimes hide their emotions, right? Yeah. Any other questions? Is there anyone from Mornington? Is there anyone from Mornington? Or maybe you have a chance to visit this cute meerkats in Mornington.
Okay.
Yeah.
Thank you.
Yeah. Thank you.